Hello guys, welcome to video number 2 where we can maybe be a little clearer as I work through these examples. I actually want to start off talking about Quentin's example, which I didn't talk about in the first video because it'll transition well. So we're looking at slide 9 from those videos and looking at Quentin. So this problem is set up just like the ones we've done so far where we could cross multiply and go from there. However, and the reason we could cross multiply is because it's a singular fraction equal to a singular fraction. So essentially one fraction each side. However, if we were to cross multiply this, notice what happens on this first diagonal. We end up with 3 different parentheses being multiplied together. So we would have to box method the x plus 1, the x minus 5, and then have to box method that result with the x plus 2. So it could get pretty extensive, pretty messy. It'll get us to x cubes. There's other options that can be a little more simple. So when we're dealing with the problems that start this lesson, when it's like the singular fractions, just one factor each, cross multiplication is great. However, when we get to these more elaborate ones, we have another option, which is just calling clearing the denominator. So what we can do here, let me write this out. We can clear the denominator, and to do that, we use the LCD, the least common denominator. The same thing we were using to add and subtract. So essentially, we want to multiply by something that makes all the denominator go away. So in this case, our least common denominator, remember we need one factor of everything, would be x minus 5. So that takes care of that factor. And then we also need the x plus 2. So that takes care of that factor. So what we can do here is we multiply both sides by x minus 5 and x plus 2. Multiply this side by x minus 5 and by x plus 2. So notice we're multiplying both sides by the same thing, so we technically aren't changing the equation at all. When we do that, we can cancel some stuff out. So the x minus 5's cancel, the x plus 2's cancel. Awesome, that's the goal. On the right side, we're just left with x plus 5. On the left side, the x minus 5's cancel, the x plus 2 is still there. So the left side has x plus 2 and x plus 1. And now we can solve from here as we would a normal problem. And in the piece, you can see in the example on that slide, it shows the solving steps from here, how that all worked out. But just so you can see, essentially we would have to use our box to multiply out this left side, x squared plus 2x plus 1x plus 2. And that equals x plus 5. We have to get everything to the same side of the problem because this is a quadratic, so subtract the x over, subtract the 5 over. And then since this is a quadratic, we would have to refactor. So this is taking us way back to all of our quadratic factoring methods. Set each equal to 0 and solve. So I went through that last part pretty quickly because really when we do these, I'll make it my goal that they normally turn into linear problems, not quadratics. Our goal is figuring out how we do this part up top, which is clearing out the denominator to make it easier to solve. So these next problems are going to emulate the same idea. So if we look at slide 11, this Seth comparing to Sidoni, they both use the same method in the end, which is clearing the denominator, but it can look super confusing in all those steps laid out. So I'm going to work through it here with you guys. So when we're dealing with these problems, we can't do the cross multiply unless it's just the singular fraction. So our goal is to clear the denominator. To figure that out, first we have to factor our denominators because we have to know what makes them, or how to get that least common denominator. So first step is to factor the denominators. Our second step is then to determine the least common denominator. And then we will use that to clear the denominators. So I will show you how that is done. Okay, so in this first step is to factor. 2 of these are already done. X minus 4 is factored, x is factored. We just need to factor this first one by taking a GCF out. So we take our GCF out of x. And when we take that out, we're left with x minus 4. Done. Second step is to determine our least common denominator. So we need an x in the denominator, check, x next. We need an x minus 4 in the denominator. And we have now, notice how I'm like checking off the factors as we go. We have one of everything, we're good to go. So now to clear the denominator, we multiply both sides, meaning we multiply every term by this common denominator. So multiply every term by that. Both sides of the equation. So essentially when I say both sides of the equation, that means every term. So we take, I'm going to rewrite this out for ourselves. X. So it's not getting too much writing on the top. Okay, so we're going to multiply this first one by x and x minus 4. This second one by x and x minus 4. And this third one by x and x minus 4. So we're multiplying everything by that term. Before we do any distributing, the whole point of this is to cancel denominators. So this first term, the x's cancel, the x minus 4's cancel. We are just left with a 6. Plus the second one, the x's cancel, x minus 4 is still there, so we're left with 4 times x minus 4. Third one, x minus 4 is canceled. We're still left with that x, so equals 2 times x. So notice, we cleared the denominators, and then we're just left with a one-line normal equation like we're used to. From here forward, we are just using normal solving techniques. So for example, we would have to distribute to get everything spread out. So we have 6 plus 4x minus 16 equals 2x. Combine some like terms. So we have 4x, if we add 16 to that, it'd be minus 8 equals 2x, and then get everything to the same side of the equation. So let's move the 4x over. And 2 minus 4x is negative 2x. Last step, divide out that negative 2. So notice all of this excessiveness at the end is all just basic equation solving pieces. And we are done. So again, the new goal are these first 3 steps up top is learning how to clear that denominator out. So I'll do one more in this video with you, that next slide, and then hopefully you guys will be able to try some on your own. So slide 12. Again, first step is to factor. This one is very similar to the one from the slide before. First step, we want to factor so we can find our least common denominator. And in this first one, we can factor out our x. So now we have to determine our least common denominator. We need an x in there. We need an x minus 2 in there. Notice we have our x, we have our x minus 2. So we've taken account for every factor. And that means we have to multiply everything by x and x minus 2. So multiply by x and x minus 2 to each term because we multiply by that least common denominator. Now we cancel out. The first one, they both cancel, so we're just left with a 10. Plus the second one, the x's cancel, so we're left with x minus 2. I'll put it in parentheses just because that's what it looks like up top. And the third one, the x minus 2's cancel, so we're left with 3x. Once we get to this step, normal equation solving. There's nothing to distribute to those parentheses, so really we can just ignore that. Oh, that's a little more than I wanted. We can just ignore that those are there. There we go. Now combine some like terms, so 10 and negative 2 gives us 8 plus, x, not 8. Subtract our 2x to the other side. Divide out our 2. And we are done. So hopefully that helps a little bit when seeing those worked out. Again, you can see the examples in the book, but it's a little confusing the way they showed the work. So we're going to use those cutouts. I know my last video said this, but I'll say it again. And we'll try A, B, C, and D on those, and I will show full work for those in a key. So you can check those and see how you're doing. Let me know if you have any questions. I'm available. We'll be doing this for a couple days just to practice it and make sure we are good to go. Otherwise, have a great day. I'll